Hi everyone, this video is on mixed exercise 9 question 14. We have the curve with the equation f of x is equal to x cubed minus 2x times e to the minus x. And in part A, we want to find the first derivative of the function. So again, it's a product rule. And what we do here is that we can consider x cubed minus 2x as one function and e to the minus x as the second function. So we want to find f dash x. I'm going to write down the first function times the derivative of the second function. So e to the minus x differentiates to minus e to the minus x. It's just the derivative of the power that comes down as a coefficient. So this is the first term. And the second term is the derivative of the first function, which is 3x squared minus 2 times the second function, which is e to the minus x. So this is our derivative, and what we want to do for the next part, we can actually take a factor of e to the minus x. So let's do that before we move on to the next part. So we can have e to the minus x, and then remember we have a negative sign here, so it's going to be minus x cubed plus 2x. And the second term from the factorization is going to be so plus 3x squared minus 2. Okay, part B, so which is the more interesting part of the question. What's happening is that basically there is the normal to C at the origin, and that intersects C again at another point. So basically the normal to the curve is intersecting this curve at 2 points. One point is the origin, and the other one is point P. So there are 2 points of intersections, and we are given one of them. We want to show that the x-coordinate of P is the solution to this equation. Okay, so what we should do is just, the usual things that we do when we want to find the equation of the normal and then the x-coordinates and, things like that. Because the first thing that here we should remember is just finding the gradient at the first place, right? We don't know the gradient yet. So what we do here is that when we want to find a gradient, we just substitute the x-coordinates of the point that the normal passes through into the first derivative, right? Into the equation of the first derivative. So we need to find f dash 0 as the first step. So it's going to be e to the 0, and then inside the bracket is going to be 0, then minus 2, and the gradient is simply equal to minus 2. This is the gradient of the tangent, by the way, because the gradient of the normal is the negative reciprocal of the gradient of the tangent line. So the gradient of the normal is equal to is a half. And now we can find the equation of the normal. So remember that the normal passes through the point 0, 0 or the origin, and the gradient is a half. So it's basically y is equal to a half x. So this is the equation of the normal. Equation of normal. Okay. Now we need just to remember a very useful fact, that if you have two equations of, two curves, a line and a curve, or two lines, and we want to find the point of intersections, we just set the two equations equal to each other, and then we solve that. The solutions are going to give us the x coordinates of the points of intersections. So in this case, we have the equation of the normal, and we know that this intersects the curve, and we also have the equation of the curve. So we just set them equal to each other, and this allows us to answer this question, which is finally getting to this point, or getting this equation. So the equation of the curve is x cubed minus 2x e to the minus x. So x cubed minus 2x e to the minus x is equal to the equation of the normal, which is just a half x. Now we just need to simplify this, and hopefully, if everything is done correctly, we should get this. Okay, so the first thing is that I'm going to divide both sides by x as the first step. And that's going to give us x squared minus 2 times e to the minus x is equal to a half. That's the first step. And if we check the form that we want to have e to the x plus 4 and then 2x squared on one side. So I'm going to multiply everything by 2 to get rid of this half first. So I'm going to get 2x squared minus 4 times e to the minus x is equal, times e to the minus x is equal to 1. And now I'm going to divide everything by e to the minus x, because this allows me to have e to the x on one side, which is positive. So 2x squared minus 4 is equal to e to the x on this side. And I'm going to add 4 to both sides, just following the form that the question is asking us, which is exactly the same as 2x squared is equal to e to the x plus 4. So that's indeed the solution to this question. Okay, that's it for this video, and thank you for watching.